for inviting me. We'd like to talk a little bit about what we do with molecular rebar, and we enable quite a few things which we'll discuss. Black Diamond Structures is the entity marketing and selling. It's owned by Molecular Rebar Design. I'm the CEO of both. It's based on technology derived by my partner and I. So it's actually, this material is out being sold for lead batteries. It's in the various development tracks of a variety of customers in batteries. It's the same technology we use for rubber and tires. What we can do with tires is reduce the weight, reduce the hysteresis, improve fuel economy, and make them tougher, stronger. In biotech, we can transfer stuff into cells. In coatings, we can make corrosion coatings last 2 or 3 times longer. 3D printing, it improves the dimensional stability and impact properties. So it's got this technology's got a broad range of uses. And the most advanced, I'd say commercially, is what we'll talk about, which is for energy storage. We can go to the next one. So one of our technology guys came up with, here are things we're trying to fix in the current lithium batteries. Our goal is to have faster charging, longer lasting, safer, and lower cost batteries. The key challenge is the charge rate's too slow. Right now, it takes taking an hour to charge a battery is not so acceptable. They're large and heavy. That's why the tires are wearing out quite a bit earlier, and they're pretty expensive, as you all know. So what we do is to help with this is on the anode side. If you add silica to the graphite, we all know the energy density goes up, but the lifetime goes down. Addition of a small amount of our material helps preserve the silica crystals. And we can get well over 1,000 cycles, or at least our customers can. And therefore, that's now makes it, enables the technology. And we're talking 15, 20, 25% silica in the anode, which then lets you someplace around 30 to 40% better energy density. On the other side of the battery and the cathode side, what we do is we replace existing carbon nanotube bundles with our material and dramatically improve the charge at high capacity rate. And we're looking at 4 or 5 times faster depending on the algorithms. I'd love to say we figured this out, but actually our customers did. We just scrambled to get ahead of them a little bit. And when you basically can take and charge faster, and then if you have much higher energy density, your batteries can get smaller, or you can go a longer distance and you can reduce cost. And then what we have is solutions, different kinds of products for each of these applications. Some are in water, some are in solvent. Our third area that we'll work on later is a new electrolyte, but this is keeping us busy. These products are all have been tested. We've worked up with, we're at 2 dozen customers. We're focused down to about 8 or 9 because that's about what we can handle. Next slide. So this is what our customers achieve. You talk all the theory you want, but it counts as what your customers see. And they see faster charging, faster discharging, improved cycle life, which was a bit of a surprise to us. And this is cycles of the whole battery. And what we're really doing is replacing the current cathode additives with very small amounts of our material. We are at the nano size, and I'll show you a picture in about a minute. And the bundles that they use today are at the micron size. In the anodes, cycle life, this is improved versus other materials, but we see, and we also see improved mechanical properties, which helps in the processing. So we make a heck of an impact on our customers And as I said, in lead batteries, we'll sell $3-4 million worth this year and double that next year. For lithium, we've got one customer all the way through. They're starting to market. The rest of them are going in the A, the B, the C, various development cycles for particularly electric vehicles. So I can't help myself. I have to show what technology actually is. Next slide. So what we do is we buy bundles from people in China, Korea, and Russia. Unfortunately, there's no real supply in US. We detangle them into the individual tubes, and those are what let us really make the magic. We have about 120 patents protecting this. They're mostly composition patents related to the individual tubes and the coatings on the tubes. Next slide. So as I said, we've got, and then basically we've organized that into 4 layers. We've got a lot of redundancy and they're scattered all over the world. So this is not so much how the tubes are made, it's their use patents. And the next one. So what do we need? Well, we're always interested in investment. We need to add more capacity. We need to add development capacity, and we need to add licensing capacity with all those patents. Our investment banker is Hamilton Clark, and there's a variety of options for this area. So thanks for the time to let me describe a little bit about what we're about.
Awesome. Thank you so much, Kurt. Opening up the floor for questions.
I can ask a question here. So what is your envisioned business model? Is it to sell formulations or to license the technology, or to be kind of more of a full solution provider, or something else entirely? And maybe it depends a bit on an industry basis. That's
a good question. Right now we're supplying a component for the various, I'll call them binders, but supplier. We do not intend to try to do the whole market. So it'll be a mixture of selling product and licensing.